Alright, in this video we're going to add and subtract radical expressions. To do this, we add and subtract like radicals, similar to adding and subtracting like terms. For example, like terms would be something like 2x plus 3x. Well, if I had 2x plus 3x, that would be the same as having 5x. When I add like terms, terms that are the same variable part, I add their coefficients together and keep the same variable part. Same idea applies with radical expressions. I've got 3 fourth roots of 2 minus 5 fourth roots of 2. Take the coefficients and put them together. 3 minus 5 is negative 2. Leave the radical part of it the same. There's negative 2 of these fourth roots of 2, and that's all I got to do here. Now, sometimes I look at them and I don't see like radicals, but maybe simplifying first would give me like radicals. Cube root of 2 is good to go because there's no perfect cube factor other than 1 that goes into 2. But then I've got the cube root of 16. Well, the cube root of 16 is the same thing as the cube root of 8 times the cube root of 2. And I picked 8 because it's a perfect cube. So that expression would turn into 2 times the cube root of 2. Now I multiply that by the 2 that I already had in front, just here. So really it's going to be 4 times the cube root of 2. That's the value of that expression. Now I had an 8 times the cube root of 2 to begin with, and I am supposed to add them together. Well, now they're the like radicals because they have the same index, 3, and the same radicand, 2. Go ahead and add the numbers in front together. 8 plus 4 is 12. So I have 12 fourth roots of 2. There's my answer. Final example. Now I got 3 to put together, and again I'll probably have to simplify a couple of these. So first off, the square root of 28, that'd be the same thing as the square root of 4 times the square root of 7, and the square root of 4 is 2. So 2 times the square root of 7 times the 2 that I had at the beginning. So 4 times the square root of 7 is what I have there. Minus 4 times the square root of 7 is pretty convenient. I think those will disappear. And then I have to simplify this square root of 63 also. Well, square root of 63, let's see, 9 is a perfect square that goes into 63, and it goes into it 7 times. So I got 3 times the square root of 7, then I'm multiplying that times the 7 that was out in front. So really I'm going to end up with plus 21 times the square root of 7. Now that they're all the square root of 7, I take 4 minus 4, which is 0, plus 21, which is 21. I'm going to have 21 square roots of 7 when all is said and done. So that's adding and subtracting like radical expressions.